Let's take a look at a test for unsaturation in hydrocarbon. On the left here in these two test tubes I have bromine water. You can see at low concentrations it appears more yellow than orange in colour, and at higher concentrations bromine water appears orange, as you see here. I'm going to use the darker solution so that it shows up better on camera. In these two test tubes I have liquid hydrocarbons. This is cyclohexene, which contains a carbon-carbon double bond in each molecule, and this is cyclohexane. It has no carbon-carbon double bonds. So let's take a look at the positive test first of all for the presence of a carbon-carbon double bond. What I'm going to do is going to take some of this bromine water. Bromine water is poisonous, so this experiment should be done in a fume cupboard. In a positive test for a carbon-carbon double bond, the colour of bromine will disappear. It will go from this orange or yellow colour to colourless, because the products formed in the reaction between bromine and the alkene are colourless. So I'll remove the bung here from the test tube containing the cyclohexene and add roughly the same volume of bromine water, and it goes. Put the stopper on here. Now at this stage, because the liquids are immiscible, the reaction would take some time, probably 30 minutes or more. But if I shake the two chemicals through one another, the reaction will occur very quickly. So at the moment we've got the bromine water on the bottom, that's an aqueous solution of bromine, and on the top we've got the cyclohexene. What I'm now going to do is shake the liquids through one another and watch what happens. And there you see the result. The bromine water has been decolorized. Let's try that now with the cyclohexane here on the right. So again, I'll add roughly the same volume of bromine water. We're expecting a negative result this time. We're expecting the colour of the bromine water to persist, to remain. Now there is another little bit of theory involved here. The bromine is currently dissolved in the lower layer, dissolved in the water, or aqueous layer. When I shake them, the colour of the bromine water will persist, or the colour of the bromine, I should say, will persist. But because bromine is more soluble in the non-polar solvent layer at the top, more soluble in the cyclohexane, it will swap solvents, and its colour will change a little bit, as you'll see. So let's shake them. And the colour, you can see, is persisting. And I'll allow that to settle for a few moments. There is a rule in chemistry: like dissolves like. Polar things dissolve best in polar solvents, non-polar things dissolve best in non-polar solvents. Bromine Br2 is a non-polar molecule, and it's much more soluble in the non-polar cyclohexane layer at the top. It has moved from the lower layer to the top layer, from the aqueous layer into the non-polar cyclohexane, in which it's more soluble. But the key thing as far as this test is concerned for unsaturation, this molecule, these molecules, cyclohexene molecules, have a carbon-carbon double bond, and they decolorized the bromine water. It went from a yellow-orange colour to colourless. This was cyclohexane. Contains nothing but carbon-carbon single bonds, said to be saturated. It gave a negative result, though the bromine did change from the lower layer to the upper layer, in which it was more soluble. We see the colour of the bromine still present.